Designing a 3-speed gearbox mechanism involves several mechanical and engineering considerations. Below, I'll outline a basic conceptual approach to creating a simple 3-speed gearbox mechanism for educational purposes. Keep in mind that actual design and implementation may require more detailed analysis and engineering expertise. Step 1. Understand the basics of gearboxes. Before diving into the design, ensure you have a solid understanding of gear types, spur gears, helical gears, etc., gear ratios, power transmission, and mechanical principles. Step 2. Define gear ratios. Determine the desired gear ratios for each speed. Gear ratios define the relationship between the input and output speeds of the gearbox. For a 3-speed gearbox, you'll need 3 different gear ratios. Step 3. Select gear types. Choose the type of gears you'll be using in your gearbox. Spur gears are simpler to manufacture, while helical gears provide smoother operation but are more complex to design. Step 4. Design the gearbox. Input shaft. This is where the power is inputted into the gearbox. Connect the input shaft to the engine or motor. Gears and gear ratios. Arrange the gears on intermediate shafts in such a way that you achieve the desired gear ratios. The gear ratios determine how the input speed is transformed into the output speed. Shift mechanism. Create a mechanism that allows you to shift between the different gears. This can involve sliding gears on shafts, engaging, disengaging gears, or other methods. Output shaft. Connect the output shaft to the wheels or the load you want to drive. Step 5. Calculate gear sizes. Use the gear ratios to calculate the sizes of the individual gears. You can use gear ratio formulas and standard gear tooth profiles to determine the number of teeth for each gear. Step 6. Ensure proper alignment. Proper alignment of gears is crucial for smooth and efficient operation. Make sure the gears mesh correctly and are appropriately spaced. Step 7. Build a prototype. Construct a prototype of your gearbox mechanism. This could involve 3D printing, machining, or other fabrication methods. Test the prototype to ensure the gears engage smoothly and the shifting mechanism works correctly. Step 8. Refine and optimize. Based on your prototype testing, make any necessary adjustments to improve the design, alignment, and overall performance of the gearbox. Step 9. Safety considerations. Ensure that your gearbox design is safe to use and can handle the expected loads and stresses. Lubrication is also essential to reduce friction and wear. Step 10. Documentation and presentation. Create detailed documentation of your gearbox mechanism, including design drawings, calculations, and assembly instructions. You might also consider creating a presentation or report explaining your design and the engineering principles involved. Remember that designing a functional gearbox requires a solid foundation in mechanical engineering principles and practical hands-on experience. It's also important to note that this is a simplified overview. The actual design process can be more intricate, involving detailed calculations, material selection, and precise manufacturing techniques.